All right, so let's continue. All right, so this is the all right, so this is the entire part which we're looking, and I mentioned that we wrote the data and we performed the external table. So that's the part which we supposed to look. So this is another DDL. Is a DDL? Yes, another DDL which you can perform. You can use the trunk instead of deleting your table, instead of removing your table, instead of dropping your table, you can use the truncate, just erase the content from your table. It's like, consider the case of emptying your bottle instead of throwing it into the trash. So you just empty it, remove the water, and then you clean it, but keep it at home, instead of taking it and then throw it into the trash. So truncate is very useful when you want to remove the data which may be in your data, but you still need to retain the structure of your table. Okay, is a drop. This is the way we saw the way we can drop the table. I can drop some of my table there. Just want to drop the following. Let me okay, so show databases, and I say use default. I don't need to call it. Show tables, drop table sample. Oops, it's not drum. Draw table sample, show table. Sorry. Show tables, drop or truncate. Let me say select star from student TTB, and then I say truncate over the table student TTB. Okay. All right. If I say select star from student TB, nothing is there, right? But the schema is retained. If I say describe student TB, schema is still there. So the structure of the table is still there. You just remove the data which was there, like the example I gave you of a bottle and the water. So you may want to, to either you decided to throw the bottle which you purchased, or you decide to keep it, but clean the, the bottle which you purchased. So this is called the trunket. All right, so for the rest of the part, you can do by yourselves. Once again, if we drop this one, let's say drop student TB, sorry, drop table. So this way we dropped it. So if again you want to describe it, it says table not found, table is not there. The table is not there because we dropped it. So you can either choose to trunk it or you can use to drop it. So the difference is drop is delete. And there is a difference between delete and erase in certain areas, based on the context. You may delete something completely or you may erase, but the existing structure is still there. Okay? Delete you may consider it like destruct. You destroy, destroy. For example, if I erase the board, I only clean the content. But if I destroy this table, what will happen? Just I remove the entire table as well. Now, what is the next point here to look? All right, so this was all about the table. For the case of renaming, I just want to, for the case of renaming, I remain with you. You perform the rest of the work. I just want to put here, this will be plus assignment 2. Okay. Beside what I gave you here, which one did I give you? This one. I bring this down here. Okay, sorry. This is assignment 1 plus assignment. You demonstrate this way of starting values into table from as it is shown in this statement. Okay, so you should not modify, please. I will check. Due date. But the due date would be Tuesday by 9 p.m. You may say Tuesday, you may put next week, right? So Tuesday will be, which date are we? Today we're 16, right? 17. And PKK time. So you may say, you may put, the time for you as time, so it will be different. This is one. The second one, use, this is assignment 1. Assignment 2, the assignment 2 will be to provide a short peer drive, scenario where external table and internal to explain the advantage of external table. The same view. Be the same view. Will be the same view. So this will be enough. This is 2 assignments will be there. It's very short. Just real life scenario I explain here. Real life scenario, for example, you look at an open door, you look it, and then you can be able to explain external table in real life examples. Okay, real life examples. As somebody who's explaining a toddler or a young boy from grade 1, right? Let me put here so you will not be able to be confused of what I'm saying here. Like explaining it to grade 4 student, grade 4 student. That will be more easy, right? Okay. So next part, which you're going to look now, for reference of this, I will post this in a, not posting, I will just open the submission in a Moodle. So you need to get reference from what I mentioned here. Hopefully it's not overloaded. This is very simple. Next week we're going for holidays, right? So holidays are starting. So you need to earn your points before the holiday starts. I mentioned deadline is strictly followed, missing 0. So here we look to the one more interesting part, which is called partition. We have a very short time, but in case if you find it's too much, please raise your hand, let me know. Okay, but they're all connected the same, very well, very easy to understand. What does it mean, partition? What does it mean, partitioning? Pardon me? Pertain? Or you want to part it? Yeah. Okay. So you can part, things. Okay. Another meaning. Pardon me? Divide. We want to divide. If you take, let's say you have 10, let's say you have 10 pens, and you want these 10 pens to be distributed to 5 people. How many pens each person has to have? 10 pens, you want to distribute these 10 pens to 10 people. To 5 people. Each person will have 2 pens, right? Each person will have 2 pens. Now, what will be easy way of doing this? What will be the easy way of, distributing these 2 pens to each person? Anyone? Okay, excellent. That was waiting. You can go, you give one by one. What's the second way? What other way? The word of what Mr. Songnam says, you can go give, you give one by one, right? What is another way? You just want to distribute these pens. Another way, you will set what? Rules. You say each person has to take maximum 2 pens. And you put pen there and they come and pick, right? They can come and pick. Or you go, you distribute. So when we say about partitioning, keep in mind that we are studying big data. And here is in the form of volume, huge data set. It is not easy to query. For example, start from this into, let's say, into 1 TB size of data. You know, thousands rows are there. So select will be slow. To make this process of retrieving data from Hive become more fast, we need to divide them into partitions, into parts. Okay, so I will explain this with this example. Explain this with example which can help you to understand. So take an example of a folder. Let's say this is called folder. Okay, consider this as a folder. All right, consider this as a folder. And every folder, what does folder contains? Folder contains, what are inside the folder? What do we have inside the folder? Every folder has what? Files, right? Every folder will have a file. Okay, every folder will have a file. Every folder will have a file. Let's say, sorry. Oops, why do I erase it? Every folder will have a file. Let's say this is another file. This is another file. This is another file, and so on. And this is the file which are all from this table. All right. So these are what? I named this one as a file. Not getting what I want. So you consider this to be the file. So these are the files of folder, files inside folder, right inside the folder. These are the files which you may have inside a folder. I may put here. I think this one will be much easier if I put here at the side. Or the file which are broken from the folder. Okay, broken from the folder. Let's say this is a file 1. We have a different files. This can be, let's say, this is gonna be file 1. This is gonna be file 1. And this is gonna be file 2. And this is gonna be file 3. And this is gonna be file 4. File 4. Keep in mind that this file, they're all residing in a folder. Or I can make, or they came from the folder. We can have a different ways. We can, design different ways. Let's say this is a folder, and I have the following files. I have the following files. I have the following files here. These are the files which I have. They are inside my folder. All right, they're inside my folder. So so they're inside my folder. Oops. Okay, so these are the things which you may need, which you may need. So in a folder, we can divide the files in order to make the process become more easy. below the file, or let's say these are the file which we have here. You can also arrange in such a way. This one, let's say, let me add one more part here. Let's say this part which I'm going to add here. Just observe this carefully. This one, I may name this as subfolder. Subfolder. This is a subfolder. So we have the main folder, which is the top here. We have the subfolder, which contains also the files. So it's like folder within a folder. So partitions is the same case. Consider this to be the table. I take this as, let's say, this folder is equal to table, right? The folder is equal to what? To a table. And subtable, let's say this subfolder is like the part of the table which you want to divide based on the column. Okay, this one, it's just, you know, this you can consider as partition of table or a subtable if you can give the name as a subtable. Let me put it here. It is the size to be. Okay, just make it small like this. Okay, a subtable. So partition is doing the same. Why? Because we want the speed to be much faster when you treat the data. So you have to divide the table into small parts so you can be able to access them. Okay, you can be able to access them. Come back to this part here for partition. The same way we organize the data. So another meaning, partition means data organization in such a way that it will become more easy. For example, if you want to rearrange this bookshelf, what will you do to make it more faster? Categories. Okay, you can arrange them on category. Based on the observance, based on what you see, how will you arrange this table, this shelf in an easy way? Okay, alphabetical will be easy. Yes, I accept alphabetical. Another way. First. By subject. By subject, okay. Alphabetical by subject, correct. Another way. Based on observation, what you see. How can you arrange this? Okay, by the size of good. Good. Okay, another way. By color. That's what I wanted. So you want to make it more easy. You said, okay, I want all the arrows to be there. I want all the grids to be here so that a person, let's say, yellow stands for programming. So you go in a yellow, you can be able easily to search. So you can group them in a different ways. So same way, Hive partition is going to do this work. We want to organize, let's say this is entire table you have. So you want to partition based on color, based on subject, based on names, you can do that. Right? So this data organization. So is a way of distributing the data load horizontally. You remember horizontal, vertically? Horizontal means what? Divide into different segments. Vertical, keep increasing the size. Right? So we want to divide, to distribute them horizontally into more manageable chunks or directories and subdirectories. This is the beautiful definition which you ever get about partition. But understand, you need to start from the scratch, understanding the purpose of partition. We need to access the data in a very efficient way. Okay? This is a definition of what? Partition. And you can explain through a real life scenario example as well. You can have a different examples. So I will give you also assignment on this where you need to don't give me definition at this part, give me a meaningful part of it. Either you can use a spoon and a plate, you can give me different examples. That's what I would expect. So this allows us to organize the data in a more logical form, correct? If we look to this one, it may sound like normalization in database, right? Normalization database, right? So that it may have the same, concept. So what and why do we need partition? I mentioned. So this is the main problem. What's the problem? When you query in a Hive, it scans the entire Hive table. So if you have entire Hive table, then it's very takes time. Remember, Hive in throughput and latency is a quite slower compared to other DBMS. So this is the main part here which we have. So this is going to slow down the performance when querying large data files. That's what I mentioned. So to solve that problem, you need to do what? Create Hive partition. As you go, you work, for example, in the industry or somewhere, you have huge data, let's say, for past 1 year. So instead of scanning or querying the entire data set, what you need to do? You need to partition based on the categories. So each partition here, important point, underline this. Please you underline this part. Important for you to understand this concept. You underline this portion here, not underlining. Each partition corresponds to what? Predefined partition column. Means partition is based on column, not on the table, on column. Partition is done on the column level. From where? Table. Okay, from table. Example. As a student, I give an example. As a student, we have a table which takes student name, student age. How will you partition this entire university student? What will be the criteria if you have these two columns, name and age? How would you partition? How would you organize? Yes, Anwar.
We organize by department.
Department is not included. I gave you age and the name.
No.
Anyone? Joshua. Group by age. Yes. So you can say, I want age column to be my partition. So let's say students who are 20, 15, so you can group based on the age. So it's easy for you to locate. Let's say we want to check the students who are, for example, if somebody is 21 years old, he may be a sophomore or a junior. So it's easy for you to locate. So you can make analysis on that. So we can group by age. So the key point is here is there's a predefined partition column or columns. Okay. So there are two ways to organize the data in a Hive. Number one, we can do by partitioning static partition. Key important here. Static what? Partition. Static partition means specified partition, in which you want to roll. It means you specify before. That's called static partition. Second way, dynamic partition. This is dynamic partition. It automatically decides which column is going to be, is going to divide them, it's going to happen automatically when you load the data inside. So two parts. So we shall focus on static and dynamic. It can be experimented either. By the way, these two parts I will schedule to be submitted after maybe, oh no, next week we have one day. Do you have a class next week? No? Till next month?
Yes.
So you want to give the assignment during the holiday. Okay. So there's no assignment during holiday.
So the mine is still not working. Have you saw the video? Have you watched the video?
Which one?
The Hive.
I asked you access, you didn't grant me access.
No, you didn't send me anything.
I said, grant me access. Check. The same
Just now I just opened my Teams. I didn't get any message.
Check from your Teams because I cannot open it.
You are not asking me anything.
No. I clicked on it. Check where it is. So I asked you access. Let me see. Wait. A minute. James and John. If I try to open here, says you need permission. So look, Limbs and John. I'm waiting. Even on Thursday again, I would like to access, please. So I was not able to get it. If I send it, I shoot it again. Again now. So I know he recorded, he sent me the installation of Hive on Ubuntu. So I did not get access. So that's what I was mentioning. Come back here. Here we have a dynamic static partition, which can happen two ways. So the first way, we can either organize the data into, we need to specify the partition. The second way, it can happen during the road. You remember the road here, which is mentioned during installation. During insert, okay? It can happen. So we can enable those two by setting this set Hive, execute dynamic partition, set Hive, execute dynamic partition mode, no strict. Okay, by default they are set, they are not enabled, they're disabled, they're false. So you need to set them true. The same way I explained this, just to focus on what we mentioned there. So we want to partition product based on the color or the gender, based on the gender, and again from the gender, based on the category, shirt, jeans based on the color as well. Okay, this is one more way to get it. Remember, this is product is what? Look here. What is the product? Product is? Database? No. We don't partition database. What do we partition? Table. Product is what? Table. Male and the female is what? Columns. Excellent. Now, shirt, jeans, shoes. What are they? You can consider them as also columns which you create. So it's a partition of the male, right? It's a partition of the male. So product is a table, male and female are the columns. These you partition based on the male and the female. Down, if you consider this shirt, jeans to be also the columns, then color is going to be column. Okay, so this is, yes, please.
So, okay, I'm looking at the table and the situation is proximate.
Pardon me?
I'm looking at the way we have.
Yes, please.
And something proximate. So the way the elements are being divided, so we have like the
Product.
the first element.
Yes, please.
So products that are found in the same, like for example, pieces of clothing which men and women. So how do you separate them or do you use some sort of?
Yeah, you partition that way based on the column. For example, create a table name product. Now, column name, first one is a male string, second female string. Now, when you partition, you either select partition female. Then when you insert the data, we know where to go. Do I address your question? Okay, please repeat again. Maybe I have.
So I'm trying to make it literal. We have the partition from male.
Okay.
So pieces of clothing is both male and female.
Yes.
Like you said.
Okay.
So how do you relate?
Okay, good. Here, thank you. I did not hear what I'm saying. I thought you were mentioning what we have here. If you add unisex dress here, you put another column here.
So you just
Call it unisex. And then you can partition based on the unisex. Right? That's what you can do. So if you cannot create what is not there, just add one more column called unisex. Because now gender has increased, right? Has become more than 2. All right, so you can increase that one. Okay, good. So any question, another question? So if there's no question, now let's start one part here. To start one part, we are going to do this as a first exercise which you want to make. And then this will help you to understand what we're mentioning now. So this is the part which we're going to create. So we are going to create the following. We're going to create a file which we give the name as a student info CSV. For the sake of time, we will not include all the columns. I will omit like age, okay? Just for the sake of time. This is the syntax we are going to follow. Create a table, look here. Maybe you are looking from your screen. Create a table. The table name is a student info. We do the same as usual, right? You create the first table as usual. We load the data inside. First, we create the CSV file with a name and a course, only name and a course. Second, we create a table with a name and a course. We take the name of student and a course. Okay, we load this file, student info, into the table created. Next part here, the way we partition here, we create another table. Step number 3. We create another table, which is called student info partition. And we mentioned, this one will be omitted. We don't need student integer or ID, or we can add it, no problem. So instead of putting this column into the same line here, we keep the keyword partition. We say partition by course string, and then the rest will be different. The rest will be the same. The only part is right here into partition. That's the only keyword which you need to add. If you understand the reason why we need partition, then this will be much easier for you to do. All right, so let's do it. Now, after that, we wrote the data. We come to write the data in this way. This is another part which we'll add. Any question here? Okay, I know we can learn through practice. Let's come here and then we do the first part. First part here, I want to, first part I'm going to create, a file. I say nano student underscore info.csv, and I put roll number. Let's say the roll number is a 2020, okay, 2020 11, and then I put camera is gonna be Winia, and the Winia is taking big data course. Just for you to understand, the file which you are creating, it's we want to register the student based on the course. So we can partition based on the course which the student is taking. That's the main part. Right? So here, 2020, 21. Oh, 2021, 01. We have NOL, and it's taking database design. I take 2019, 01. I have Scott. He's taking big data. I have 2019, 01. Zudawe. He's taking database design. 2018, 01. I have Usonda is taking big data. So let me add one more, 20, let's say 2017, 01. I have Edora is taking big data. 2021, 01. I have, what is name? Songnam. Is taking database design. It's a big data, a problem. All right, so I save the file. Student info, that's a file. And in student info, I'm going to create a second step. I'm going to create a table. Create table, and we say if not exist, I'm going to call student underscore info, where I'm going to have student underscore ID, integer. I say student underscore name, string, and I have here course underscore name, string, say low format delimited field terminated by comma, right? By comma, and then load data local in path. In path, what do we have there? Student underscore info.csv into table student underscore info. Okay, now select star from student underscore info, where course underscore course underscore name is equal to big data. Okay, so this is one fetch which you can perform. So we have this one just to confirm. You can either select or just do this. This select where cost is equal to big data. Same. So this is the first part. So now second part which you are going to make here, we are going to create a partition table. Okay, you're going to create a partition table. So the partition table is going to be clear as this. Say create table if not exists, okay, student info underscore partitions. Okay, I call it part. So here I give as follow. I say student ID, correct? I say integer. I say student name, string. Here is a thing. Here, after creating this one, I put here, say, partitioned by course name, string, and I say low format field, low format, how do you put that one? Low format what? Low format, and followed by low format delimited fields terminated by comma. All right, done. Describe student underscore info underscore part. You see now here, it mentioned the partition which we have here. The column name which is partitioned here is a course name string. Okay, this is the heart of it. This is the heart of it. We partition based on the column. Next part is a simple. Next part we're going to roll from the previous file, from the previous table to this one. Okay, this is it. Concept, if you understand concept, very, very simple. Same creation, you know how to create a table. Now you need to specify how do you want to partition. Here, you want to partition based on what? Course name. Who are taking a big data? Who are taking database design? Okay. So we perform this. Look at this. So the next part here, we add the following. Okay. From student info, insert override. The override keyword means we write if there's something in the table, it's going to overwrite. Okay. So we specify the table which you want to overwrite. Okay, which you want to overwrite, and it's gonna write inside that one. So let's write that one. So here we're going to select from, say, from student underscore info, from student underscore info, insert overwrite, we insert overwrite table student underscore info underscore part. This is it here. If you don't, please, if in the case it's fast, let me know. Here we have a student info part. This is the table we created. If you give different name, then you need to substitute here. All right, so info, and here is a keyword. Partition. How did we partition? We partition based on the course name. Okay, based on what? Based on the course name which we provided, right? Based on the course name, right? As we select ID, student, what is the first one? Did we mention student underscore ID, comma, student underscore name, and we provided course underscore name. Okay, course underscore name. This part, listen here, this part, this one, sorry, there's a double type. This one is from the what? From the student info table. This is from the student info table. This column. You want to select from there, right? If there's an error, there may be a typing mistake here. All right, important part. Important part. As the table has learned, it will throw this error. Do you remember I mentioned about dynamic and what? Static. So here we need to set them. Okay? By default, I mentioned they are what? By default, they are disabled. So we need to enable them. So we do the following. We say set Hive execute dynamic partition is equal to true. Set Hive dot execute dynamic dot partition dot mod is equal to no strict. Okay, true. So we need to enable it dynamically and statically. So we made it statically, right? How did we make statically? We specified the column here. So again, I execute here. I say, where was it? Okay, done now. So this is the last part. Okay. So it's execute everything here. Check, 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 check. It is subject. Okay, excellent. Now here, select from what? Student underscore info underscore which one? Part. Okay, so it grouped them. Do you see the way they're grouped? The big data they're there. This is down here. I will show you in the next class where we can find this. Okay, how we can find the way they're divided into this one. So this is the heart of the big data in terms of analysis, in terms of querying from a huge data. Suppose in a country you want to group the people based on, let's say, during COVID, based on the high temperature in a day, those who get 90%. So you can do this partition based on temperature. So it can show you high, slow, medium, moderate. So you can do that. Okay? Yes, please. This is what I did. I changed. This is what I did. Here I was enabling them. By default, set false or is disabled. So you have to enable it by doing this. Welcome. So till we meet in next class.